Hello friends, myself Rohit Vijay Bhavsar. Today we are going to see comparison between electric vehicle and hybrid vehicle. Let's start. This is the abstract part. Introduction of electric vehicle. Single the beginnings of the end for traditional engine vehicles. The major motivator for shifting to EVs are the need for reducing polluting engine emission and reducing dependence on costly oil fuels. So here we know electric vehicle is a basic need for our new generation. So it is important part. Let's see. Introduction. The development of automobile powered by internal combustion engine ICE was one of the greatest engineering achievement toward the end of 19th century. The availability of low cost fuels, easy to use, increased reliability and long driving range boosted the acceptance of these vehicles. However, vehicles propelled by heat engines are very poor in fuel efficiency. It's 20-25%. Beside the combustions of hydrocarbon fuels in these vehicles release many toxic gases. Today, after more than century, the automotive industry and the large number of vehicles in use around the world are causing serious concern for the public and the environment. So let's start. The transport sector is a major contributor of air pollution beside electricity and heat generation industries. As shown in figure shows that electric and heat 24%, transport 24% and industry 19%. World CO2 emissions from fuel combustion by sector. This is IEA report 2017. So here some basic information about EVs and hybrid electric vehicle. So this table shows vehicle linked gases and global warming potential. Carbon dioxide CO2 1, methyl CH4 25, nitrogen N2O 298, AC refrigerant HFC 134A is 1430. Electric vehicle technology. Basic structure of electric vehicle you can see uh, here battery, motor generator and transmission is used for running electric vehicle. Electric vehicle is used electric motor for propulsion in place of conventional IC engine. Engine driven vehicles work on the principle of combustion, get their energy from carbon based fossil fuels. In contrast, EVs can use electricity generated through a wide range of resources such as fossil and non fossil hydrocarbons, hydronuclear power, and renewables. Electricity is transmitted to the vehicles through overhead power lines. Direct connection through cables or wireless energy transfer by using a storage system. The energy may then be stored on board the vehicle. So here some basic structure and arranging of electric vehicle equipments and basic structure of electric vehicle. So main comparison between IC engine and hybrid electric vehicle. IC engine, powertrain IC engine, high specific energy of fuel, power density high, emits greenhouse gases, travels 300 miles fill, short refilling time 5 minutes, fuel tank takes less space, fuel weight is very less, higher maintenance cost, braking energy not recovered, running cost high, engine efficiency 30%, needs complex gear system, noisy operation, ample refiling infrastructure, need to pick up some speed to deliver maximum torque, use only hydrocarbons. Electric vehicle (EVs), powertrain motor plus engine, low specific energy of battery, power density low, no tailpipe emissions, travels 100 miles, charge, long charging time 0.5 8 hours. Battery takes large space, batteries are very heavy, lesser maintenance cost, can recover braking energy, running cost low, motor efficiency 80%, needs only one gear, quiet operation, lacks charging infrastructure, produces maximum torque instantly after starting of motor, use electricity for many resources. So here we see comparison of engine vehicles versus electric vehicles, terminology associated with EVs. So here some terminologies which is associated with EVs. Let's see. uh, Basic arrangement of an EV's drivetrain. EVs can be classified as a battery electric vehicle BEV and hybrid electric vehicles HEV. Pure EVs have only battery as their energy source. A vehicle that has two or more energy sources and energy converts is called hybrid electric vehicle. So HV with an electric powertrain is called a hybrid EVs. The sources of energy used in HEVs can be combination of many resources such as battery, petrol, biofuels and fuel cells. Battery powered EVs usually have larger storage battery than HEVs. Travel range is one of the most important difference between BEVs and HEVs, battery electric vehicles and hybrid electric vehicles. Comparison of systems and function of ICEV and BEV. So function ICEV vehicle and battery electric vehicle. First, energy source, fuel tank, and here electric vehicle for battery. Replenishing the energy, petrol pump, charger. Production of motive force, IC engine, electric motor. Control speed and power, carburetor, electronic controller. Auxiliary power supply, alternator, DC or DC converter. Based on the type of transmission, clutch, gearbox, differential, and the number of motors, a variety of EV configuration are possible. This is shown in figure 5, starting from the oldest design to most advanced design. So here we show the design of electric vehicle which is based on old models. Let's see. Vehicles with a clutch, a multi-speed gearbox and a differential. These EVs are modified versions of IC vehicles with motor in place of engines. So here we see electric vehicles have clutch, multi-speed gearbox and differential somewhat. This is modified version of IC vehicle with motor in place of engines. EVs with the fixed ratio gearbox and a differential, they do not use clutch as the electric motor that has constant power, which is in electric vehicle. So battery electric vehicles are propelled by electric motor by using energy stored on board in batteries. There are many similarities between an IC engine vehicle and battery electric vehicle, a brief list of which is summarized in table 4. To recharge the batteries of BEV periodically, they must be plugged into an external source of electricity. So normally electric vehicle has a plug for charge their battery. The latest innovation in electric vehicle is the inbuilt configuration. In this design, as shown in figure 6, separated motor known as in-wheel motor are installed at each wheel. Mounting the motor and power electronic with a wheel assembly can improve efficiency, save then give designer more flexibility in body design. It is possible to regulate drive torque and braking force independently at each wheel without the need for any complex transmission or drive shaft. Range braking capability of in wheels is very high, about 85%. This design will require drive motor with higher torque to start and accelerate the vehicle. In wheel motor of capacity up to 75 kilowatt in currently available hybrid electric vehicle. The biggest advantage of IC engine vehicle in the long drive range due to the high energy density of petrol fuel. Through battery, EVs possess many advantages over conventional engine vehicles such as zero pollution, high efficiency, etc. Their travel range per battery can charge is much very less than in engine vehicles due to the lower energy content of batteries. Hybrid electric vehicles have the benefit of both ICE vehicles and electric vehicles and overcome their individual disadvantages. Arrangement of an in-wheel motor here shown in diagram. So see, series hybrid electric vehicles is SHEV. So here brief information is given about SHEV. Parallel hybrid electric vehicle PHEV. So both are reliable. Complex hybrid vehicle. This is a combination of electric vehicle and hybrid vehicle. The CHEV. Fuel cell hybrid electric vehicle PHEV. Fuel cell hybrid electric vehicle series hybrid configuration in which fuel cell is the energy conservation system and battery or a supercapacitor is the energy storage system to deliver peak acceleration power. Plug-in hybrid electric vehicle PHEV. The basic difference between a standard HEV and plug-in HEV is shown in figure 9. Plug-in hybrid vehicles are full hybrid which use a smaller engine, a large battery and a large motor. Batteries of PHEVs can be recharged from any external power source unlike in standard HEVs in which batteries are recharged only by means of the engine driven generator or range braking. This feature of PHEV has the advantage of drawing electricity from any resources such as grid power including household supply, autonomous system of even renewable energy. PHEVs have shorter all electric driven range per charge as against battery EVs but have a large all electric range as compared to standard HEVs because the engine generator drive can assist the system when the batteries are depleted. Also owning the large electric motor, PHEVs have higher range braking capability compared to traditional HEVs. So here the diagram which shows comparison of standard HEV and PHEV. See the diagram and travel range of typical PHEV different modes acceleration, long distance trip, daily travel to workplace. It is 20 to 30 kilometer only electricity and classification and features of hybrid EVs. So this is about batteries. We normally use lithium ion batteries because that battery is very useful battery and it is high range of charging and charge. Batteries possess very low energy density as compared to liquid fuels. Energy density for petrol is 12,500 kgs, whereas the same for lead acid La batteries is 3545 weight kilo kg, and for lithium ion batteries is 20. Batteries are both large in mass and volume compared to petrol diesel tank carrying the equal amount of energy. To get the same energy output from a battery as that from a fuel tank, a large battery pack is required. As sample to get the equivalent energy output of 4 liters of petrol is need a 275 kg LA battery pack. This is a major drawback of EVs affecting the maximum all electric range of these vehicles. Number of traction battery technologies exist today. The LA batteries being the cheapest are used in very small EVs such as golf carts, e-rickshaw, saw, etc. To a lesser event, nickel cadmium batteries are also used. However, the current two major battery technology used in EVs are nickel metal hybrid and lithium ion. So here a chart of lithium ion batteries. Batteries are for electric vehicle and their driving range and their capacity of use, mass energy density. EV battery charging method. So here charging method is shown in this figure 14. So figure shows that the electric vehicle have charger system just like similar to our phone, just with that have charger which is plug in the car. So here the table comparison of conduction and induction EV charging, power rating, typical efficiency, charging time and weight and EVs. Way forward and conclusion to EVs. The further is electric for surface transport as the earth will run out of petroleum fuels within 50 to 60 years. Electric vehicles offer many advantages, increasing nation's energy security, the reducing oil consumption, supporting to climate change inactivities by reducing harmful emission, reduce public health risk on account of poor air quality and long-term economic growth through the introduction of new technology and infrastructure. There are, however, many technical and social economic changes to overcome before the widespread acceptance of EVs. These include high capital cost, shorter drive range, long charging time, heavy weight and large size of battery and the need for fast charging facilities. Electric vehicles are clean only at the point of use. Reduction in vehicular pollution through EV development will be more meaningful if they are powered by electricity produced from clean resources to avoid pollution otherwise caused by generating station based on fossil fuels. A smart application of EVs is the grid to vehicle and vehicle to grid concept. In figure 19 we see in which energy flow to and from the vehicle, turning it into a distribute energy stored system. During lean hour of power demand, EV battery are charged using a grid power, and during peak hours battery discharge power to grid. By this mode of operation, EV can act as either a load charging or generator discharging as needed. When aggregated in large number. This capability of EVs will become an important part of the smart grid. This is references from you can take information about electric vehicles and hybrid vehicles and IC engine vehicles. So thank you so much.